So for today's topic, we're going to be talking about preventative and proactive maintenance strategies for PROFIBUS DP networks. This is one of my favorite topics. It's one that I speak about a lot. We recently did a lot of talks with, in conjunction with the SIMC, and we spoke about a similar topic, how to make your network have the highest possible availability and what are some of the considerations that should be taken into account when you have a PROFIBUS DP network or you're responsible for the maintenance and uptime of a PROFIBUS DP network. Right, so very often I find that people don't fully know what IDEX actually does. Some people think we're the PROFIBUS gurus or the guys who deal with PROFIBUS. That is true. Some people think we do gateways that convert between different protocols. Other people know us just as software developers that specialize in communication systems integrating between disparate type systems. The truth is we do all of that, and this slide shows pretty much what we do, so I'll explain it quickly. The slide shows the various data communication systems that can be identified on a site. We add value to our customer base by creating a bridge between disparate communication layers and enabling effective and efficient communication channels. We have a software, we've created software, and we have the know-how to integrate all the communication systems from low-level field devices all the way through to MIS management systems, ERP systems, and eventually cloud type systems as well. Did you know that IDEX has a fully developed data historian system? Our historian integrates through multiple different layers, from fetching data directly from field level devices, control systems, supervisory systems, and integrating directly into ERP type systems and eventually cloud and IoT type services. But today we're going to be talking about this lower level over here, PROFIBUS DP, the data communication between field devices and control systems. So first, and one of the most important topics, training. Any industrial communication system has some complex concepts behind it that require quite a bit of understanding and installation guidelines, and training on how these systems should be installed and how to effectively utilize these systems is paramount. Firstly, technology-specific training on the PROFIBUS system itself. It's important that maintenance staff and engineers understand the installation guidelines, audit procedures for ensuring that the network is healthy, have some learnings into how to effectively fault find and troubleshoot these networks, and how to also take full advantage of all the features that PROFIBUS DP can offer, and there's a huge amount. Even more so with newer technologies such as PROFINET IO. It's also important that system integrators that are working within industry attend this training for PROFIBUS installation engineers type courses so that they know how to effectively install the systems and manage these type of systems. In addition, one of my absolutely got me really excited last year is that I found a lot of industries are taking a proactive approach to train their staff on future implemented technologies. So prior to actually installing the type systems, and even before the design phase, they're making sure that their engineers, design engineers and maintenance staff understand how the system works prior to actually making decisions whether they're going to implement the system. And that's pretty important, because I think one of the biggest downfalls which PROFIBUS has suffered in the past is that it is installed badly outside of the guidelines, and that ends up causing failures. And unfortunately, it's given the technology at some instances maybe a bad reputation that PROFIBUS doesn't work. And I can promise you today, PROFIBUS works perfectly well if it's installed well from the beginning. It'll never give you 1 ounce of loss of sleep. So hopefully we can do the same, learn how to properly implement PROFINET and alternative industrial Ethernet technologies going forward to make sure that we install them correctly from the beginning. Certified versus uncertified training. So IDEX is a fully certified and accredited PROFIBUS and PROFINET training center. We are accredited by PROFIBUS International, or PI, the organization that creates the specification for the PROFIBUS and PROFINET technologies. And we're also a certified competency center, meaning that we offer expertise and competence into industry for these technologies. So the biggest advantages of attending certified training is that all of our engineers get fully up to date with the latest developments on the specification, what works in industry. We have experienced trainers that eat, sleep, PROFIBUS and PROFINET. More often we don't sleep because we're fixing plants. But we also offer international certification certificates for all our courses, which is quite well respected in industry and recognized internationally. Testing tools. So very much you can learn a lot about PROFIBUS and how it should be installed and understand the guidelines. But because it's a digital communication system, you're a little bit blind unless you have effective testing tools to give you eyes into the network, give you statistics, and give you some sort of health analysis on the network so that you as a PROFIBUS engineer can make decisions on it. So I do suggest that when investing in testing tools, make sure that your staff are well trained up on how to utilize these tools. Ensure that the tool is available to everybody who might need it during a shift. And I would even suggest that the company, you ask them to come and do a live site demo on your running plant to see how the system will work and how it will actually add value into your network. What I do find excessively important is a PROFIBUS or PROFINET, specifically a PROFIBUS testing tool, can only be as useful to a person who has knowledge on how the tool can assist them. And what I mean by that is, my favorite example is a multimeter example. You cannot purchase a multimeter and give it to an untrained personnel who does not understand the concepts around electricity. He wouldn't pretty much understand how to use it or understand what the readings actually mean and how he can use that to identify electrical faults. And just much like PROFIBUS, a PROFIBUS testing tool unfortunately may not assist you as well to identify faults and to check the health of your network unless you understand the core principles around PROFIBUS and the PROFIBUS guidelines. The tool will give you statistics and it'll give you various tools to pick up symptoms within the network. But unless you understand what those symptoms mean, it often will not be as useful as possible. So very important, get the foundation-based training on the PROFIBUS protocol, get the training on the test tools, understand how those test tools work. So maybe not training, but very important for maintenance staff to understand how the devices on their network actually operate. So the various different I/O or field level devices, how to configure them, how the devices, how they behave when the devices fail or they do certain things. PLCs and controllers often give you a lot of statistics and logs. What do these statistics and logs in the PLC mean, and how can they help identify various faults? The first thing I'll do when I walk into a plant suffering a potential breakdown is ask them what certain logs they have stored so I can try and point me in the right direction as to where I can potentially look for a problem on the network. And lastly, fault finding and experiential learning. Something that's been pretty useful, I think, into industry that we've been offering in the past is once personnel have attended training on the PROFIBUS, PROFINET technologies, maybe got some testing tools and that, is actually having the experiential learning and having a professional, somebody who has a lot of experience in fault finding and auditing PROFIBUS networks to come and join them on their plant. So maybe we do a day's engineering, go through the networks on the plant and show the personnel the process and I suppose the industry hacks into how to identify various different faults and have a look into certain situations. And I think that's extremely valuable. I've always said that the technicians and engineers that follow myself and my colleagues around site when we're attending a breakdown or an audit become the most knowledgeable people on the site on PROFIBUS, PROFINET technologies, because we just love to talk about everything that we find. We love to share our knowledge with the personnel on site, show them why certain situations occur and how to prevent them in the future. And we often find they're a lot better off at the end. So point number 2, diagnostic tools. What sort of tools do we need in the network? As much as my first step when walking onto a plant to do an audit or a call out is to do a visual inspection of the network, look at, I suppose, cable wiring runs, have a look at how connectors are wired, have a look at the type of devices installed on the network, the addresses which the devices have been assigned. I would be pretty blind unless I had a certain set of tools that could connect into the network and give me some visibility and overall health analysis of the network. PROFIBUS DP is a high-speed digital system, which means that unfortunately a multimeter is not going to assist me very much in identifying communication failures. It does become pretty useful for identifying like wiring shorts on PROFIBUS PA networks, checking power supplies to your devices, but there's a couple of specific PROFIBUS or high-speed digital system tools, such as oscilloscopes and cable testers, that we should probably be investing in that can help assist us with ensuring our network has a good health associated with it. So the first one, a very basic cable tester. A device like this shouldn't have too many steps or procedures. You see there's a nice big test button on this device. Simply plug it in. Once you've installed a wiring loop, in PROFIBUS you could often have 30 connectors on a single segment, and trust me, it's very easy to create a wiring fault or short when you're wiring up a long network, especially in hot, stressful environments. Very often on site, I've created wiring shorts completely by accident. As soon as I've connected a whole lot of cables together, I'll immediately check the cable, make sure that I've done everything correctly before connecting it into the devices. A bus monitor goes a little bit past a cable tester. He will ultimately interpret the telegrams on the bus, and he has various tools integrated into him that helps identify faults and symptoms. An example of bus monitors that we use on a day-to-day basis would be the Percentic products, such as ProfiTrace and Mercury. The bus monitor will very often have an integrated high-speed oscilloscope. Oscilloscope normally has to have a frequency of above 100 megahertz. Yeah, the oscilloscope, the biggest advantage of having an oscilloscope is it gives us a view at the underlying waveform on the network, which is definitely the most key indicator of the overall network health. What you would always expect to see on a PROFIBUS network would be a nice square and even waveform running through the network. A waveform that is distorted or changed from what I just drew could indicate anything from EMI, so interference from high voltage cables and noisy devices. It could indicate wiring faults. It could indicate missing terminations. So very quickly, the first thing we look for is the scope healthy and square? If not, then there could be some underlying issues into the network as well. The bus monitor should give you an overall health analysis. It should be able to give you an overview of the network state and ultimate check, is the network healthy, or is there certain things surrounding the network's performance that give it a low or a high possibility of failure. Very often these tools can generate reports for you, PDF documents that allow you to create a snapshot in time of the network's state at the time of measuring that device. And lastly, one thing PROFIBUS engineers love is statistics. Statistics are very useful to us to identify issues, whether they're from recurring faults or intermittent faults. Some of the statistics that we use when diagnosing PROFIBUS networks are things like sinks. A sink statistic is a counter where a PLC is being programmed to communicate with the device, but the device is not available on the network. Whether the device is locked out, disconnected, power off, or failed, a sink will indicate to you that the PLC is trying to establish communication, but that device is not there. Illegal messages is always a scary statistic. Illegal messages means that a telegram traveling along the PROFIBUS network has been damaged somewhere along the line. This could have been due to EMI, wiring faults, duplicate addresses. Illegal messages are detected by a certain network component, such as a bus monitor would detect and count illegal messages and would tell you which device originated that illegal message or where it was due to go to. It picks up illegal messages through detecting parity or bit parity errors in the telegram, or if the telegram does not follow the correct specification, such as the correct number of bytes and certain starter limiters and length indicators and so on and so forth. Another statistic would be repeats. Repeats is where a PLC tries to communicate with a field device. The field device does not respond after a certain timeout, so the PLC will retry or repeat this telegram to that device. The repeat message can be set in controllers, so you could set it to 3, 4, 5, or even just 1 repeat if you wanted to move on. And the last counter or useful statistic would be something called lost devices. Lost device is where a I/O device is not heard from the PLC within a certain time period. That's called a watchdog timeout, and then that device will ultimately shut off or go into a safe state, and that's pretty much where plants will start experiencing trips on their network. Permanent health monitoring. So very, very prevalent in today's day and age. Having a tool that you can connect into your PROFIBUS network that will monitor that network around the clock. It should give you remote access capability to connect into the network from anywhere. I'm sure you can all imagine why that's excessively important in today's unfortunate events. It should be able to give you alarms, alarming on the network, indicate when there is faults. So remote access, as maybe a PROFIBUS engineer sitting at home, possibly a couple of 100 kilometers away from site, late at night, when the operator indicates to you that there is a network failure, it can be dangerous for you to get into your car, have to travel to site, endangering staff personnel, but often unnecessarily having to travel all that way. And also above the dangers to site personnel is incurring unnecessary costs as well. So staff should be able to remote into the device, have a look at the overview of the network health, and possibly they can pick up what might have gone wrong with the network. The device permanent health monitoring should give you alarming events. Should be able to send you a simple email, SMS, or even set off a siren somewhere in the plant to say, listen, this PROFIBUS network has an issue. And whether that issue has caused a failure of the network yet doesn't really matter, but you want to know that that network is not running at its optimal possible performance so that you can correct issues before you get an expensive, unnecessary breakdown. Taking advantage of remote and centralized resources. So very good example, maybe you are you have a head office with multiple sites around the country. You could have a resource or an engineer that specializes in PROFIBUS networks, and instead of having to travel to all the different sites, he has remote access into all those different sites, and he can give recommendations to the operators and personnel sitting on the site. IDEX, we have some pretty decent PROFIBUS engineers working here who on a day-to-day basis receive trace reports from sites. They get access or remote VPN access into these Combricks, also permanent health monitoring type systems that allows them to have a look at the overall network health and give some indication and idea into what potentially might be failing on the network without having to take an expensive trip or a necessary trip to site. Identifying intermittent faults. I always keep a permanent monitoring tool in my tool bag when I go to site. Sometimes it occurs that there's a problem that I can just not figure out. I cannot see the symptoms of it. Everything I try does not cause the problem to go away. Or maybe the problem only occurs every 6 hours. And I'm going to get pretty tired if I sit there with my laptop plugged into the network for 6 hours. So in some severe situations, I can connect a permanent monitoring tool. It would very often have a memory card in it that could log any statistics or failure indicators when the network failure occurs. Go home, have a cup of tea, come back in the morning and figure out what the problem is on the network. Very often you would find like a failed device or some intermittent process, underlying process that is causing the failure, and then we could take some mitigation strategies to correct that. And ultimately, the whole topic of this webinar is preventative maintenance, and a permanent monitoring or permanent health monitoring tool is the core solution to preventative maintenance on your network. Network audit. So a network audit should be run not when the network is failed or failing or causing breakdowns, but ultimately to ensure that the network has the highest possible availability and health that it possibly can have. Now, important thing to remember is that PROFIBUS networks are dynamic. What I mean by that is very often I would get a request from a site that they would like to certify their networks. They want a certificate that indicates that network is 100% and will never fail. And unfortunately, I'll never give a certificate like that. And the reason is networks are dynamic. On plants, very often you're running high voltage cabling, you're expanding the network, you're adding on future devices. Devices might get damaged within Rio panels, possibly from rain or dust. You could have pests on site that could be eating through cables. So what a network audit should be basically doing is saying at this point in time, the network was installed according to PROFIBUS specifications and guidelines, and the network has a high availability. But because networks are dynamic, this network audit should be repeated over and over again. How often or how frequent that is, I suppose it depends on your site. If it's an excessively important network, you might want to run a network audit monthly, every 6 months, once a year, maybe just during your routine shutdown and maintenance, have your plant personnel connect into the network and do a snapshot in time. How is that network looking? Very often external parties might be required to verify new installations and upgrades. If a system integrator or a large vendor has won a installation project, they might require an external sign-off. This is where the PCC or my company becomes excessively useful, where we can actually come in as a third party without any hidden agendas to identify any failures that may occur in the network and correct the problem before it causes site issues, and then obviously give mechanisms for appropriate sign-off at that point. What you should expect from a network audit. Well, during our PROFIBUS Engineers course, we do touch on the topic of how to effectively do network audits, and obviously I would suggest taking a bunch of experiential learning from having a professional on site show you how the audit procedure is done. But basically a visual inspection, make sure that all the cables are run in the correct cable category separation. So I'm removing my PROFIBUS cable from any noisy devices or cables. The wiring, the good wiring of all the PROFIBUS connectors, devicing and network diagrams are up to date. And then eventually the engineers should actually connect in some bus monitors and testing tools. Have a look at that nice square waveform I was talking about in the previous slide, and make sure that the network has a very healthy appearance to it. At which point you should get a full report, and the report can indicate any potential risks that need to be corrected on the network, or indicate where the network or what the network looked like in that snapshot in time. Number 5, environmental considerations. So there was a brilliant standard that was released by PROFIBUS International about a year ago. It's called the Functional Earthing and Bonding for PROFIBUS and PROFINET Networks. And it's brilliant. It's available completely free of charge on their website. If you go to profibus.com, have a look at downloads, find it somewhere along the subsets there. If you would like me to send it through to you, just send me a mail or drop your mail in the Q&A, and I'll send that document through to you after this as well. And this has become more and more prevalent because functional bonding, earthing and bonding is absolutely critical to the health and sustainability of networks on site. What the standard pretty much covers is things such as, has about 6 recommendations, and the recommendations are explained why they implement that recommendation, how you should implement that recommendation. And some of the recommendations are like the power distribution system that you're implementing. They recommend you use TNS, which is where your transformer supplies your 3 live phases, a neutral phase, but a separate protective earth line from the transformer. And you're not using TNC or pen bridges, anything which can cause damaging earth loop currents. It talks about potential equalization lines that should be installed in the network and how you should properly bond cabinets and substations together, components within your machinery as well. It talks about the cable shielding, cable separation, and there's quite a few other things. So definitely have a read through that standard. It is brilliant. During our PROFIBUS and PROFINET courses, I always spend about an hour or two going through the 6 recommendations, just to give the attendees an indication of what is a good process to follow with regards to earthing and bonding. IP. So in case you didn't know what IP stands for ingress protection. It's basically a rating table that indicates how well a device can protect itself from solid ingress and water ingress, mainly around electronic components. So normally IP has 2 numbers to it. The first number indicates solid protection, and the second number indicates its protection mechanism from water. So for example, if you see IP20 on a device, it means that it can protect from like fingers. You can't put a finger in the device, but it'll have no protection from any water whatsoever. So if that device is out in the rain, it's going to get damaged. An IP rating of 65, for example, indicates a full protection from dust, and the 5 indicates that there's protection of low pressure water jets from any direction. So a device like this could probably be installed in the field and protect itself from the elements. Cable type and run route. PROFIBUS cannot just use any type of cable. It's very important that you install PROFIBUS DP specific cable. The reason behind this is the electrical properties of the cable are very specific to the protocol itself. It needs to have a very specific impedance property as well. And using other types of cable, for example, using PROFIBUS PA cable and DP cable installation is going to cause endless issues on the network. What's also important is using the appropriate cable for the application. So if you have a cable running out in the field that is exposed to the sun, you need to have a UV protection cable. Bringing a cable under the ground between substations needs to be armored. And then obviously cables running around very hot areas such as furnaces and that should have the necessary fire and heat protection from them as well, but more likely you'll probably be using fiber optics in that case. Run route, it's always recommended that you use fiber optics between substations and only resort to using copper within panels, purely because fiber optics is immune to interferences such as EMI, as well as potential equalization issues where you might have 2 different potentials and 2 different substations, and it opts to use your PROFIBUS shield to balance out those substations. But nonetheless, if you're using copper between panels or between rooms on a plant, that cable should be run in appropriate conduiting, preferably steel conduiting or aluminium, that has various protection mechanisms against EMI and can also protect the cable from pests and damage with site elements as well. Talking about pests, I have a funny story. I was conducting an audit at a plant in South Africa a couple of years ago, and as I was unclipping a cable rack to have a look for a potential fault that I suspected to be in there, a rat jumped out, jumped on my hard hat and ran down my back. So needless to say, I jumped up and down like a pansy, and the engineer behind me thought I was actually being electrocuted with how pathetic I was performing. But nonetheless, I found my problem on the PROFIBUS network. The rat had made a nice cozy nest next to his cable and was snacking on the DP cable, actually causing a wiring short. So pest control within plants, especially in the food and beverage industry, is excessively important. And a point I haven't listed here that comes to mind as well is rear panels that are installed within the field that have IP20 devices installed on them. It's very important to ensure that those rear panels are always closed and that they are properly sealed according to their IP rating, as things like coal dust, other types of dust and moisture can severely damage devices, and that can often be a very difficult problem to identify throughout the network. Bus segmentation. So this is always a great one. Very often on a PROFIBUS network, you'd have various different categories of devices. So For example, you would have your PLC, you would have I/O, you could have your VSDs or actuators that often tend to be quite noisy, and then you might have some RIO panels out in the field. Apologies for my messy drawing, I'm trying to do it with my finger. Connecting this up in a PROFIBUS standard, which means that all devices are linked to each other, sharing the same cable. You could link all four of these subset of devices together. Now, the concern behind this is if you tend to get some noise or interference that is affecting your VSDs, this is not just going to affect your VSDs, but it's going to affect your I/O. It's going to affect your PLC communications, and it's going to affect the communications coming from the RIO panel, which could cause a full network breakdown or failure between devices. So what is often a better option is to use something called bus segmentation. So segmenting a network into logical segments or multiple logical segments using things such as multi-channel repeaters, which have optical isolation within them by optocouplers, or using fiber optics to create this logical segmentation as well. Application of where this makes sense, you have your PLC, you have your I/O, you have your noisy VSDs and actuators, and you have your RIO panel. So now, instead of linking all these network components together, we can rather install a multi-channel repeater that can give a separate segment to each one of these subcategories of devices. And this, when the VSDs cause intermittent EMI or interference on the network, the I/O is protected, the PLCs are protected, and the RIO panels are protected, and all the noise is isolated just to this segment, which should prevent unnecessary breakdowns in the network. Bus segmentation can be done by utilizing multi-channel repeaters, as indicated below. Fiber optics can be used for bus segmentation, but very often fiber optics is useful for running between substations and running long distances. Fiber optics is completely immune to any interference or noise, which is excessively useful between substations, as you could have different potentials of those substations, which can cause a lot of havoc in the communications. You can also run fiber optics right along your power cables running throughout the plant, and it will not be a problem. A lot of these devices, such as fiber optic repeaters and multi-channel repeaters, have something called bit correction, where if there's a noisy signal on one segment that's quite distorted, it will clean that signal up, boost the level to give you a neater and clean signal on other segments, thus preventing cross interference between multiple different segments. It also is brilliant for EMI type prevention. And another interesting concept is protection of PLCs. PLC or control systems are often one of the most expensive components in your network, costing anything from tens of thousands to hundreds of thousands of rands. And apart from that, it is the probably one of the more important components in your network to ensure continued operation. Very often within the field, you could get some damage or short circuits or even some surges, lightning strikes, whatever it may be, that can cause damage to your devices. So by connecting either a multi-channel repeater or preferably fiber optics between your PLC and the rest of the field, you're going to protect your PLC from those field level interferences, surges, or things that can potentially cause harm or damage to your PLC. So it is often good practice and common practice to install a repeater at your PLC prior to running cables into the field, or even to run direct PLC to fiber optics and then distribute your communications utilizing fiber optics. Life cycle of devices. So I don't know if you've heard about burn-in testing. So most devices fail pretty much at the beginning of a device's life, so prior to being installed, and then obviously once the device's lifespan has come up, and it's pretty much what we call burn out. So when devices start failing, And Burnin testing is where a company takes a proactive approach. So a manufacturer of PROFIBUS components connects the manufactured device to a network, runs millions of telegrams through the device, checks all the electrical behavior of the device, and ensures that the device performs according to its specification and build prior to chucking on a QA sticker onto the device and sending it off to site. This is excessively useful, and it's often very useful to ask the vendors that you deal with and the manufacturers, do they conduct burn-in testing on their components so that your site during your operations does not perform that function and identify faulty devices out of the box. Alternatively, components, you can do burn-in testing at your sites within your workshops, connect your device you want to install in your network to a PLC within the workshop, let it run for with a bus monitor attached to it for a couple of days, make sure that the device does perform how it is supposed to. Prior to installing that, will also make sure that you have the right settings in the device, such as the device address and configuration build as such. Device lifespan. So if you look at the mean time before failure of various different components installed in a network, it might range from 15 years to, I've seen components that have a mean time before failure of 146 years. And I find that very unlikely, but that's probably what all the electronic components in the device are rated to. So device lifespan, from our experience or from what I've seen, is typically about 15 years on a PROFIBUS network. And I think it's a very good consideration to firstly make sure you keep spares in stock for devices that are older. Look to do upgrades once networks start becoming a little bit older. And also keep in mind that when you have an older network that's 15 to 20 years old, that when you have breakdowns and you're doing an audit, to take into consideration that a device failure might be the cause of the error. And a device failure is a very difficult problem to identify. Very often, to identify these faults, we have to do isolation of the network. So I need to disconnect various different devices on the network and see if the problem goes away. Once I've identified the suspect device, I should connect them directly to a bus monitor and see if the device does the same intermittent failing behavior one-to-one rather than in an entire bus. Keeping spares in store, excessively important, especially for devices that have a very long lead time. And I know some of the vendors for spares, especially such as like PROFIBUS interface cards, can take months to supply a spare. And you really don't want to have your plant standing because you can't get hold of a $200 PROFIBUS interface card for a VSD. So keeping spares in store, especially for critical components, is excessively useful. You should also train staff up and at least know how to configure and program these devices when you need to replace them. For your PLCs, ensure that you have a backup of your PLC program stored on file. And this is excessively important for legacy type devices where the original system integrator or PLC programmer might not have that spare for you. So when you need to replace a PLC and you've lost your program, it's going to cause quite an expensive rebuild. Redundancy and reliability. So our best advice on redundancy and reliability is make sure that when you're implementing redundant type connections and systems, that it is actually a true redundant connection. An example of this is if you have a PLC, a critical component, you have a PLC and he's connected to an IO device in the field. You want to make sure that that IO device, no matter what, cannot fail for whatsoever reason. So you run 4 redundant cables between the single PLC and the single IO device using some sort of component, maybe use a multi-channel repeater or a hub that often support these redundant lines. But in this case, your cable probably isn't your weakest point in that installation, is it? Your weakest point is ultimately going to be your PLC and your IO device. So if you want to create a true redundant and safe system, you probably should not have 4 cables running, but maybe look at alternative redundant installations. So it's mainly identifying what is the weakest link in my installation and trying to mitigate that risk. There's often very useful technologies that can get integrated into PROFIBUS, such for fiber optics, implementing fiber rings, where an OLM has two ways to actually communicate between the different OLMs. So if one of your fiber links is broken or damaged in the field, it has a redundant path to maintain its communication. For copper, you can utilize things like a Y-link. Alternatively, use things like PROFIBUS, which also give you redundant cable runs. And then there's considerations around redundant PLCs and having a smart PLC switch to redundant devices, having two devices that can perform the same function quite quickly. Another point on redundancy and reliability is when implementing redundant systems, ensure that you fully understand how the redundant system should be implemented, understand the architecture behind it, and how devices are to be set up. It's very often that I have attended unnecessary breakdowns because a redundant system did not just fail to provide redundancy, but actually caused the failure on the network. An example of this is if you had to create a redundant fiber link, optical link. If all the OLMs connected in that optical link are not configured for the redundant link, you're going to end up causing something called duplicate telegrams traveling through the bus. The OLM will not know that it needs to drop one of its links and only communicate a message to one path. So it'll share that message through multiple paths, which is going to cause a very sure failure on the network. So ensuring that devices that are supposed to be redundant are configured properly will ensure continued health in the network as well. And lastly, for proactive and preventative maintenance strategies for PROFIBUS DP networks, these are steps that will be repeated again and again. Plants evolve, technology is updated, and business focus change. Accept that the requirements to maintain your systems and look for new mechanisms to prevent unwanted performance will be an ever-changing and expanding step. So that's it from my systems. And yeah, thank you very much for joining today. If you do have any questions, please feel free to send through an email.